Hi, geometry friends. We're going to look at the first topic in Unit 7. Unit 7 is all about equations of lines and circles. And so the first thing we're going to look at in topic 1 are equations for lines parallel and perpendicular. So the goal of the lesson is to be able to determine if lines are parallel, perpendicular, or neither, and also writing an equation of a line that is parallel or perpendicular to a given line through a given point. Now, to remember that when you have lines that are parallel, they have the same slope. So let me highlight this in yellow. So lines that are parallel have the same slope. So wherever we see the word parallel, we should think same slope. And then alternatively, in blue here, it says if lines are perpendicular, then they have negative reciprocal slopes. Okay, so let's talk about that thing right there, negative reciprocal, real quick. So when lines have negative reciprocal slopes, what would that look like? Okay, so in a general form, here's an example. In a general form, that when you have a negative reciprocal slope, so let's say one slope of a line is A over B, okay? So the negative reciprocal of A over B is negate that value and reciprocate or flip it over. So it would be a negative B over A. That's what a negative reciprocal is. You're doing two things. You're negating the value of that number and also flipping it over. Okay, so how about if I have another example, like if I have negative 3 over 2. Okay, so if my slope is negative 3 over 2, what is the negative reciprocal of negative 3 over 2? So what do you think? This would be positive 2 over 3. So if you said positive 2 over 3, that was the right idea. Now, how about one more thing? If I give you an example and say, what if I have a slope of 3? So if I calculate the slope of a line and it the slope is 3, what's the negative reciprocal of the value of 3? So consider if I made 3 into a fraction. So you can make any number a fraction if you put that number over 1, because dividing by 1 keeps it the same. So now if I started with the number 3 is really 3 over 1. And if I do the negative reciprocal of 3 over 1, it would be negative 1 over 3. Okay, so that's what negative reciprocal means, is you're going to take the value of that number and you're going to negate it and flip it over. So if you start with a positive, your value will be negative. You start with a negative, the value will be positive, and then you also flip that over. Now, one of the things that would be most helpful in the questions that we're going to look at is if you can identify the different forms for the equations of lines. Because if you can identify that form, then you'll kind of save yourself some algebra work. If you really like algebra and you would rather kind of manipulate equations so that they all look the same, you can do that. But if you can recognize a form of a line, then you might have a better, kind of more efficient and quicker way to answer that question. Okay, so let's start over here with standard form of a line. So it says ax plus by equals c. And in this case, a and b and c all are coefficients. They should represent a number. So it could be like 2x plus 3y equals 5. That's an example of a standard form. So you have a is the coefficient, the number in front of x, and b is the coefficient of y, and then it's equal to some other thing over here, some number over here. Now, one of the things that we can take away from this is if you see an equation written in standard form, then what you can determine is what the slope is of that line without having to do much work at all. Okay, so let me show you what that would look like. So when an equation is in standard form, the slope of that line is negative a, and take the value of a and negate it and divide that by b. So when you see a line that's in standard form, the slope is negative a over b. Now, another form is called slope-intercept form. And this is the form that would be most useful if you are graphing or trying to graph a line, or trying to look at a graph and try to write the equation. So slope-intercept form is best for when graphing. And some of the features here. So when you look at the equation, it's called slope-intercept form because there's two different variables in here. There's the m and there's the b. And one of them, m, is the slope. So the slope is the coefficient of x here. It's m. And then the other thing that we know is that b is the y-intercept. And again, this is most useful when you are trying to graph a line. Now, the last form of the line is called point-slope form. And the equation looks like this right here. Y minus y1 is equal to m times x minus x1. So in this form, there's really three different numbers that we need to be aware of. There's the y1 value here, there's m value there, and there's x1 value there. The y and the x are the variables for the line. The kind of independent and dependent variables. And then there's these numbers, y1, m, and x1 will change with each equation. So in this, they call it point-slope form because, again, the name of this line is exactly what you need to write it, the equation. You need a point and you need a slope. So the slope is still the variable m. Okay, now the point in this case would be called x1 and y1. X1, Y1 would be a point that's on that line. And so this form of a line is most useful when you're asked to write an equation of a specific line that goes through a special point. And we'll see a couple of those. So these are the three different features, or the three different forms, of lines. And if it's not one of these three things, then what we can do is we can kind of like manipulate that equation to make it one of these three forms. Okay, so let's look at a couple example questions here and see how I can do this. All right, so down here it says, for number one, we want to know which two lines are parallel. So I'm going to highlight that. Sorry, not in blue. I wanted to highlight that in yellow because up above I said when lines are parallel, they have to have the same slope. So what I'm doing is I'm going to look at line I and II and III, those three lines, and I'm going to try to see which of those lines have the same slope. Well, it's hard to tell in the forms they currently are in because what you see here, this first choice, 4x plus 14y equals 2. If I'm going to try to match that with what form that's in, this form looks just like standard form. A is 4, B is 14, and C is 2. So that form looks exactly like standard form. Okay, so it would be simple for me to first identify that and then also determine the slope of that line. So for the first line, we said that's standard form, and the slope of standard form is always negative A over B. So it's negative 4 over 14. And one way you might want to redraw that or rewrite that is the slope, or M, would be negative 2 over 7. Okay, so if I was going to simplify that fraction, it would be negative 2 over 7. Now, let's talk about this next line. Okay, so here's the first one there, and let's talk about the next one here. So this one, I look at this and I say, what can I recognize that form? Y minus 2 is equal to negative 2 over 7 times x plus 4. So that form is just like point-slope form. Y minus 2, or y1, is equal to m, the slope, times x minus x1. So if I was going to talk about the features of this line, it would look like this. So this is point-slope form. That means the slope of this line is this variable, or this coefficient right here. It's negative 2 over 7. And the point, negative 4, positive 2, is on the line. Now, why is it a negative here? Because look at the standard, or the kind of generic form of this. See how it has a minus sign here and a minus sign there? So when I see a plus sign there, that means I was subtracting a negative, and therefore the x variable, or the x part of the point, has to be a negative number. And the y, since this is a minus, I'm changing that sign and making a positive. So you just kind of change the signs. So in the second one here has we have a point slope form. Here's the slope. There's a point that's on that line. Now, the third one is not in any one of these forms. See, 7y equals 2x plus 6. That's not exactly standard form because the x is the x term is not on the same side of the equal sign as the y term. It's not exactly slope-intercept form because it doesn't have y all by itself. And it's certainly far from what the point slope form line looks like. So what I need to do is basically do a little algebra and manipulate this equation so that it looks like one of these three so I can determine what the slope is. Because when I want to find lines that are parallel, I have to determine slope from each of these lines. So I think it would be make most sense for me to write this equation in slope-intercept form. And to do that, I would have to divide each of the three terms by 7. So when I rewrite it, I would have y all by itself is equal to 2 over 7, 2 divided by 7. I'll just leave it as 2 over 7x, and then plus 6 over 7. Okay, so now I know this. Now I know that this equation is written in slope-intercept form. The slope is 2 over 7, and the y-intercept is 6 over 7. But now that I have all the information from each of these equations, I can go back to what I was intending to do in the first place and say which lines are parallel. So I'm looking at slope in each case. So the slope of the first line is negative 2 over 7. The slope of the second line is also negative 2 over 7. But the slope of the third line is positive 2 over 7. So this one does not fit the other two. Therefore, only lines 1 and 2 are the lines that are parallel to each other. Okay, how about this one down here? Which statement describes the following two lines? So you have here a line right here, you've got a line right there, and we want to say, are those lines parallel to each other? Are those lines perpendicular to each other? So parallel means same slope. Perpendicular means negative reciprocal slopes. And if it's not one of these two things, it has to be one of these two choices. They either are intersecting but do not make a right angle as if they would perpendicular lines, or they are the same line. And it might be, they're obviously not the same equation, but that doesn't mean they're not the same line yet because they are in two different forms. So let's break down each one and kind of see what we know about them. So having looked at each line carefully, I have this line is in point slope form. So the slope of the line is the 2/3, and the point positive 6, positive 5 is a point that's on that line. So that's what I know about this first line. The second line is written in standard form. And the one thing I know I can take away from this is the slope is the value of negative a over b. So the a is the 12. And now here's one thing you got to be very careful about. The b term is actually this negative 18 number, because you remember, if you look at the general form, see how it has a positive sign right here? And since this is a negative, that means my b term must be negative. So if I negate a and divide that by b, then it's a negative 12 divided by a negative 18, which is a positive 2/3. And now to determine which of these four choices is the best choice, I'm going to compare the slopes of those lines. And the slope of the first line is 2/3. And then the slope here is also 2/3, which means that these lines must be parallel to one another. Okay. How about question 3? Determine and state the equation for a line that is, it says right here, perpendicular. I can't highlight that. Let me use my drawing tool in blue. The line is perpendicular right here. So when I see perpendicular, I have to consider a negative reciprocal slope. It has to be perpendicular to this line and passing through this point. Okay, so I had to go perpendicular to this given line and passing through this point. So let's consider what I know about the given line right here. And let me write some stuff down. So over here, I had the line y, or 5x, minus 4y equals 10. That line is written in standard form. So that means I know the slope of that line is the negative a over b. So a is 5, so I have a negative 5 divided by b is a negative 4. So the slope of my given line is 5 over 4. Now, I said before that if lines are perpendicular, they have to have negative reciprocal slopes. And so what that means is I'm going to take the given slope, 5 over 4. So I'm going to say m, the given slope was 5/4, but then I'm going to have this symbol right here. Watch this. M is for slope, and then I'm going to put the perpendicular sign. So the slope originally was 5/4. The slope of a perpendicular is the negative reciprocal of that, so it's negative 4/5. Okay, and now here's the two things that I need to use. I have to use, let me circle it like this. I have to use this point. My line, the equation that I'm going to write has to go through this point and be perpendicular. So use this slope. So if I know it, I have to use the point 512 and the slope negative 4/5, then the most efficient way for me to answer this question is using the point slope form of a line. So let's see what that'll look like. So point slope form is y minus y1 is equal to m times x minus x1. So the point is my x1 and my y1. So the 5 is x1, the 12 is y1, and my slope m is going to be the negative 4/5. So my answer can be written like this. Y minus 12 is equal to the slope negative 4/5 times x minus 5. And this is an acceptable form for the answer because any form that's similar to this is correct. You can write your answer in point slope form, or you can manipulate this and write it in slope intercept form or even standard form. But that's the way we can get to my answer. But when I want to write an equation of a line that is either parallel or perpendicular to a given line through a special point slope form makes the most sense. Okay, how about this question right here? So now I have the lines that are represented by these equations. You have this equation right here, y plus 1/2 x equals 4, and 3x plus 6y equals 12. And again, we need to decide, are those the same line? Are those lines parallel to each other? Do they have the same slope? Are they perpendicular to each other? Do they have negative reciprocal slopes? Or are they neither of those two things, neither parallel nor perpendicular? So let's go ahead and kind of assess our situation with these two lines. So the first equation, y plus 1/2 x equals 4, that was not in any one of the forms. So what I did was I decided if I subtract 1/2 x on both sides, then I would already have this in slope intercept form, because now it says y equals negative 1/2 x plus 4. So since it's now in slope intercept form, I know the slope of that line is negative 1/2 and the y-intercept is positive 4. But to answer my question, I need to look at and compare the slope of the given line that was 3x plus 6y equals 12 is a slope of negative 1/2. And then over here, I found out also the slope was negative 1/2. So again, we have lines that must be parallel to each other. Okay, one more opportunity here to compare. I have two lines, 4x plus 6y equals 6 and y equals 2/3 x minus 1. I can see that I have a standard form. I've got a slope intercept form, so this should go pretty quick. Let's kind of lay out the details here. So what we saw was with the first equation, that's written in standard form. So the slope is negative a over b, or negative 4/6, or to simplify it the most, the slope is negative 2/3. And now also we have this line, which is written in slope intercept form, and the slope is positive 2/3. So now we need to compare, because we want to decide, are those lines parallel? No. This is not the same as that. 2/3 is not the same as negative 2/3. Are they the same line? No. Are they perpendicular to each other? This is an interesting question. This is one where students would get stuck on a lot. Are they perpendicular? Is 2/3 a negative reciprocal of negative 2/3? They are negated, but are they reciprocals? No. So the last choice, they are intersecting lines, but they are not perpendicular, would be the right choice. Okay, so because they don't have slopes that are the same, they don't have slopes that are negative reciprocals, they must be the same, or they must be intersecting lines, but not perpendicular. Let me write a little note for you. They do not have the same slope nor negative reciprocal slopes. That's why they must be intersecting but not perpendicular. So there you have it. There's topic 1, part 1, lines that are parallel and perpendicular, and lines that are parallel or perpendicular through a given point.